Assalamu alaikum wa rahmatullah. Our today's lesson is about balancing redox reactions. By the end of this video, you'll be able to give examples of dry redox reactions, write the corresponding redox equations of some redox reactions, define oxidation number of an element, and identify the oxidation number of some elements. The materials needed during this session are a pen and a worksheet that include the main ideas and applications related to the video. Before we start our lesson, let's recall back some information. In the reaction of zinc with copper solution, Cu2+, the two half reactions and the overall equation are: the oxidation half reaction is Zn, undergoes oxidation by losing 2 electrons, it gives Zn2+, while the reduction half reaction is Cu2+ plus 2 electrons gives Cu. We add these two half reactions to get the overall equation, and the overall equation will be Zn plus Cu2 plus gives Zn2 plus Cu. This example shows how to write an overall equation of a redox reaction. But what if the half reactions were more complicated? What can we do? Before we start, let's watch this video about combustion of magnesium. It's important to note that the combustion reaction of any species is its reaction with oxygen. So since this reaction is combustion of magnesium, then it is the reaction between magnesium and oxygen to give a salt. Here, magnesium is in the solid state, is a metal in the solid state, while oxygen is in the gaseous state to give a salt, which is magnesium oxide. Here, magnesium, when it reacts with oxygen, here the bond between the two oxygen atoms breaks, and the magnesium atom loses 2 electrons gained by the oxygen atom to give magnesium oxide. Here we add half to balance this reaction. Then the equation can be written as Mg plus half O2 gives MgO, magnesium oxide. Now let's try to answer the following questions. First, which element gains electrons and which element loses electrons? As you can see here, magnesium is going to lose electrons and oxygen is going to gain these electrons. Then magnesium loses electrons and oxygen gains electrons. 2. Write the half reaction of each of magnesium and oxygen and assign their types as oxidation or reduction half reactions. We said that magnesium is going to lose electrons, then it undergoes oxidation. Mg gives Mg2 plus 2 electrons. And oxygen is going to gain electrons, then it undergoes reduction, and it will the half reaction will be half O2 plus 2 electrons gives O2 minus. The third question is, does this reaction involve any water or any solvent? Here we said that magnesium is in the solid state, is a metal in the solid state, and oxygen is in the gaseous state. Then it does not involve any solvent. So we say that this reaction is a dry redox reaction. Dry since it does not involve any solvent. Now let's watch another video which is for the reaction between sodium metal and chlorine gas.
And I heated it a lot until it was molten red. This time, when I placed it back into the chlorine, it was a much more spectacular reaction. The sodium burned really bright, and it turned my Erlenmeyer flask into a lantern. Now that the reaction had died down, it's possible to see the reaction going on inside the broken test tube. Compared to the other method where it was ignited using water, this method produced a lot more sodium chloride smoke. The test tube was coated in a thick layer of nice white sodium chloride. I tried to scratch off as much as I could, but it's honestly very hard and stuck very tightly to the glass. When it's poured out, you can see that this product is much cleaner than the last run.
Here a reaction takes place between sodium, which is a metal in the solid state, and chlorine, which is a gas, to give sodium chloride salt. Also, the reaction is between Na and Cl. The bond breaks between the two Cl atoms, and Na loses one electron, which is gained by chlorine, to give NaCl, which is Na plus and Cl minus, and we put half here in order to balance the equation. Then the equation of the reaction will be Na plus half Cl2 gives NaCl. Let's answer also some questions about this video. Which element gains electrons and which element loses electrons? Here you can see that Na sodium is going to lose electrons and chlorine is going to gain this electron lost by Na. Question 2. Write the half reaction of each of sodium and chlorine and assign their types as oxidation and reduction half reactions. Since Na loses electrons, then it undergoes oxidation, and since Cl gains electrons, then it undergoes reduction. The half reactions will be the oxidation half reaction. Na gives Na plus 1 electron, and the reduction half reaction is half Cl2 plus 1 electron gives Cl minus. Does this reaction also involve any water or any other solvent? Of course not, since Na is a solid and Cl is in the gaseous state. Then no. Deduce the type of this reaction. This reaction is also a dry redox reaction. Now we can give a definition for dry redox reactions. A dry redox reaction is an oxidation-reduction reaction that takes place in the absence of water or any other liquid. The reactants are in solid or gaseous state. Some examples of dry redox reactions. First, the combustion of magnesium, as we have seen, Mg plus half O2 gives MgO. Also, the reaction between sodium and chlorine, Na plus half Cl2 give NaCl, and combustion of carbon, C plus O2 gives CO2. We said that the combustion of carbon, which is C plus O2 gives CO2, is a dry redox reaction. But the transfer of electrons is not clear in this chemical reaction. So how can we determine if this reaction is a redox reaction or not? We can do it by using the oxidation number of elements, which you have taken before in grade 9. The oxidation number is an integer written usually in Roman numbers that describes the degree of oxidation of an element. It is the number of gained, lost, or shared electrons by this element when it is involved in a chemical bond. But how can we determine this number? Let's see. To assign oxidation number for an element, you have to follow the following rules. First, the oxidation number of an atom in its elemental form is 0. Example of an element in its elemental form is Fe, Cu, O2, and Cl2. Also, the oxidation number of a monoatomic ion. Monoatomic ion is an ion made up of only one atom, is equal to the charge of the ion. Example, Cu2 plus, Zn2 plus, Cl minus, Al3 plus, O2 minus. The oxidation number of each one of these ions is equal to the charge of the ion. Means that the oxidation number of Cu2 plus is plus 2. The oxidation number of Zn2 plus is also plus 2, equal to its charge. The oxidation number of Cl minus is minus 1. Al3 plus is plus 3, and O2 minus is minus 2. Now, in compounds. First, the oxidation number of elements in column 1, which are alkali metals, is plus 1. An example here is NaCl and K2S. Na is an alkali metal and K is also an alkali metal. Since these elements are alkali metals and are in compounds, then the oxidation number of these elements of Na and K is plus 1. The oxidation number of elements in column 2, which are known as alkaline earth metals, is +2. An example is MgS and CaCl2. Both Mg and Ca are alkaline earth metals and they are found in compounds, then their oxidation number is +2. The oxidation number of aluminum is always +3 in a compound. Example, AlCl3, the oxidation number of Al in this compound is +3. The oxidation number of hydrogen is +1 when combined with non-metals, while when it is combined with metals, its oxidation number is -1. An examples are HCl, H2O, H3PO4, and NaH. HCl, Cl is a non-metal. Then the oxidation number of H is +1. H2O, oxygen, is also a non-metal. Then the oxidation number of H is +1. H3PO4 also, the oxidation number of H is +1. And in NaH, Na is a metal, then the oxidation number of hydrogen is -1. The oxidation number of oxygen is -2 except in peroxides. The peroxides which are H2O2, hydrogen peroxide, Na2O2, sodium peroxide, and K2O2, potassium peroxide, it is -1. Examples, H2O. The oxidation number of oxygen in H2O is -2. In H2SO4, the oxidation number of oxygen is -2. In H2O2, since it is a peroxide, then the oxidation number of oxygen is -1. The oxidation number of fluorine is always -1 in a compound. Example, KF and MgF2. F in a compound has an oxidation number of -1 always. The oxidation number of each element in a compound is written per atom. For example, in hydrogen peroxide, the oxidation number of hydrogen is +1, whatever the subscript is. Also, the oxidation number of O is -1 since it is a peroxide, and whatever the subscript is, the oxidation number is not affected. The sum of oxidation numbers of all atoms in a compound is 0. It means that the sum of the oxidation number of each atom multiplied by the number of atoms of this atom is equal to 0. For example, here in H2SO4, we know that the oxidation number of hydrogen is +1, and we also know that the oxidation number of oxygen is -2. But we don't know anything about the oxidation number of sulfur, so we denote it by X. In order to determine X, we say that the sum of oxidation numbers of each atom multiplied by the number of atoms of this atom is equal to 0. Then the oxidation number of hydrogen, which is +1, multiplied by the number of hydrogen atoms, which is 2, +1 multiplied by 2, plus the oxidation number of sulfur, which is X, multiplied by the number of atoms of sulfur, which is 1, plus the oxidation number of oxygen, which is -2, multiplied by the number of oxygen atom, which is 4, must be equal to 0. We determine X, we find that X is equal to +6, thus the oxidation number of sulfur is +6. Here it's important to note that in a species, usually the oxidation number of only one element is to be calculated. Now, the sum of all the oxidation numbers of all atoms in a polyatomic ion is equal to the charge of the ion. Means that the sum of the oxidation number of each atom times the number of atoms is equal to the charge of the ion. Let's take an example here, PO4 3-. The oxidation number of oxygen is -2, while the oxidation number of P, we don't know anything about it, then we denote it by X. Then we say that the sum of the oxidation numbers of each atom times the number of atoms is equal to the charge of the ion. And the oxidation number of P, which is X, multiplied by the number of P atoms, which is 1, plus the oxidation number of oxygen, which is -2, multiplied by the number of oxygen atoms in this ion, which is 4, is equal to -3, equal to the charge of this polyatomic ion. We find X, it is +5, thus the oxidation number of phosphorus is +5. To understand this idea more, let's solve this application about assigning oxidation numbers. Assign the oxidation number of each element in the following compounds: H2C2O4 and NH4+. Solution. First, in H2C2O4, we know that the oxidation number of a hydrogen is +1 and the oxidation number of oxygen is -2. But we don't know anything about the oxidation number of carbon, then we denote it by X. Let X be the oxidation number of carbon. Let's remember that the sum of oxidation number of all atoms in a compound is 0. Then 2, which is the number of hydrogen atoms, multiplied by the oxidation number of hydrogen, which is +1, plus 2, which is the number of carbon atoms, multiplied by X, which is the oxidation number of carbon, plus 4, which is the number of oxygen atoms, multiplied by -2, which is the oxidation number of oxygen, must be equal to 0 since it is a compound. We find X, we find that X is equal to +3, then the oxidation number of C is +3. For the polyatomic ion NH4+, let X be the oxidation number of nitrogen, and we know that the oxidation number of hydrogen is +1. In a polyatomic ion, the sum of oxidation numbers of all atoms in an ion is equal to the charge of the ion. And NH4+ is a polyatomic ion, then the sum of all the oxidation numbers must be equal to the charge of this ion, which is +1. Then we say that we have only one nitrogen atom multiplied by its oxidation number, which is X, plus 4 hydrogen atoms multiplied by the oxidation number of hydrogen, which is +1, equal to the charge of the ion, which is +1. We find that X is equal to -3 and the oxidation number of nitrogen is -3. The summary of this video: first, a dry redox reaction is an oxidation reduction reaction that takes place in the absence of water or any other liquid. The oxidation number is an integer written in Roman numbers that describes the degree of oxidation, loss of electrons, of an atom in a chemical compound. In a species, usually the oxidation number of only one element is to be calculated. The sum of oxidation numbers of all atoms in a compound is 0. In a polyatomic ion, the sum of oxidation numbers of all atoms in an ion is equal to the charge of the ion. This video was prepared and recorded by Mr. Mustafa Tlayas and supervised by teacher Hiba Badawi.